We're at one of the current sites here in Gig Harbor, putting in the new ground frame foundation system. System was developed through a series of evolutions with the inventor when he started using these small piles driven into the ground. They're used to help establish a foundation system that is minimally disruptive to the ground surface and has been found to be very successful in transferring loads for both gravity and earthquake systems. The whole concept was developed by the inventor as a mechanical simulation of like a tree root. It started out as a four-piled system that would spread the load out through the ground like the tree roots do. And a large tree starts to seed right at the surface and spreads into the ground. This kind of foundation system to disrupt the surface of the ground very little. The system was developed by working with a geotechnical engineer who had taken similar soil samples at different sites and developed a software compatible with our determined mechanical properties of how the system works. So we're able to go to a site, get a representative soil sample of what that site is going to have, and then run that through the software to determine what length of pins are required and what diameter of the pipe would be used to establish the kind of load capacity that we want for the particular project that they're being used.
Got my print out here. I've got all my pieces of steel numbered, and those numbers will correlate with my drive log. And we'll time each and every one so that our engineer can actually tell the soil types and kind of the topography as we step up the hill here as to how fast the pins drive or how slow they drive.
Now at a site like this, we have a variable soil condition, which is a lot of fine materials, almost sandy-like, but it's got little stones in it also. And this is really a very desirable kind of a soil for driving the pins into, and is really a preferred kind of a system because it gives a good aggregate combination of resistance for both bearing and friction.
The project that we're working on here, there's a pretty big fault, almost 6 feet from one side to the other, of elevation and grade change. And that allows us, with our product, to go through pretty conveniently and shim down our steel frame bucket in a different level platform as they take those steps down. And then when the framers come in, when we're done, they can frame their walls up to the level platforms that they need to start rolling joists. And to be able to work with the sloping grade of the environment rather than having to come through and excavate this entire property to either a flat or a big step, or have a lot of work into forming things up for our concrete foundation, which would take a lot more time and a lot more money. So on a very serious note, this is the book of pin. No, this is a joke that we had on the job site. We often tease our boss because of how tight you can get the amount of waste and fall off with a project like this. If you really do your math right and you can transport any excess materials to the next site, you can have very little waste. And so we often tease him that, like, this is the amount of beam cutoff that we have towards the end of the job sometimes. And that's not a lot of waste, so we made him a little book.